You're floating out in deep space, looking down at this massive, totally featureless, spinning blue and green sphere. It's absolutely beautiful, right? But if you had to tell someone exactly where you were on that gigantic sphere, how would you even do it? I mean, before we had GPS in our pockets or satellites constantly orbiting above us, how on earth did humanity figure out how to navigate a completely blank globe?
Well, welcome to this explainer. Today we're unpacking something absolutely wild called the geographic grid. Honestly, it's basically the ultimate global hack. We're going to explore how a set of completely invisible, entirely man made lines draped over our physical planet manage to dictate our everyday reality, map our climate, control our clocks, and even guide how we travel the skies today. Here's our roadmap for today. We've got 1. Decoding the grid, 2. Earth's heat zones, 3. The math of time, 4. The international date line, and 5. Great circles. We're taking a journey from basic geometry to the literal manipulation of time and space. All right, section 1, decoding the grid, latitudes and longitudes. Let's dive right into the foundation of our global coordinates. So to actually map a sphere, we rely on two primary sets of imaginary lines, latitudes and longitudes. Latitudes are those parallel lines running horizontally east to west, and their ultimate 0-degree reference point is the equator. Longitudes, on the flip side, are the vertical meridians running north to south, and they all intersect at the poles. Their starting point is the prime meridian at 0 degrees, which is an imaginary line passing right through Greenwich, England. Now, when you overlap those horizontal latitudes with the vertical longitudes, boom, you get the geographic grid. It creates this incredibly precise intersecting matrix over the entire Earth. It's like a giant net that lets us pinpoint absolutely any location on the planet's surface with an exact set of coordinates. But just think about the sheer physical scale of the math we're talking about here. The physical distance between just one single degree of latitude is approximately 111 kilometers. That's about 69 miles. And the equator itself, that 0-degree baseline for all those horizontal lines, is a massive 40,075 kilometers long, perfectly slicing the Earth into the northern and southern hemispheres. Moving right along to section 2, Earth's heat zones, mapping, climate. Because these lines aren't just about figuring out where you are, they also tell us what the weather is going to be like when you finally get there. The really crucial point here is that latitudes actually dictate something called insolation, which is really just a fancy science term for the amount of incoming solar radiation a region gets. And this creates three distinct climate zones. First, you have the torrid zone hugging the equator. It gets direct, intense rays from the sun, making it our hottest zone. Moving outward toward the poles, we hit the temperate zones. The sun rays here hit at an angle, giving them a much milder climate. Finally, at the very top and bottom, the frigid zones receive extremely slanted rays, meaning they stay frozen and are absolutely the coldest parts of the Earth. Which brings us to section 3, the math of time. When are we? Okay, so we know exactly where we are on the grid, and we know how hot it is based on those latitudes. But here is a wild question for you. How do we know when we are? Well, the whole foundation of global timekeeping relies on one very simple physical reality we all know. The Earth is a sphere, and it completes one full 360-degree spin on its axis every 24 hours. Now, stick with me here. We're going to do a little bit of visual math. If a 360-degree rotation takes 24 hours, we can easily break that down. It means the Earth rotates exactly 15 degrees of longitude every single hour. Break that down even further. It takes exactly 4 minutes for the Earth to rotate just 1 degree of longitude. By the way, the word meridian literally means midday. And since the Earth rotates from west to east, places to the east always see the sunrise first. So the golden rule of time is this. You add time as you move east, and you subtract time as you move west. So how does all this math apply to the real world? Internationally, the globe is carved up into 24 standard time zones, with each one being roughly 15 degrees wide, representing 1 hour of that rotation. For countries with a huge east to west spread, they obviously need multiple time zones. But remarkably, massive countries like India or China have decided, mostly for political and administrative convenience, to stick to just one standard meridian for their entire territory. They literally created a single unified time zone despite their massive size. All right, section 4, the international date line, where days begin. We are now arriving at what I think is the most fascinating line on the globe, the place where days are literally born and where they die. The International Dateline, or IDL, is this imaginary line that roughly follows the 180-degree meridian straight down through the middle of the Pacific Ocean. It was established way back at the 1884 International Meridian Conference, and it acts as the exact anti-meridian, meaning it's on the complete opposite side of the Earth from the prime meridian. This is the internationally agreed-upon threshold where each new calendar day officially starts. But here is the crazy part. It doesn't go straight down. It actively zigzags all over the place. Why? Simply to avoid splitting single island nations and territories into two entirely different days. It takes this huge detour around northeastern Russia and Alaska's Aleutian Islands. Amazingly, the nation of Kiribati was actually split into two different calendar days until 1995, when they basically said, enough, and legally moved the international dateline to wrap around their islands. So, practically speaking, you have to understand the rules of crossing this line. If you cross the IDL heading east, you subtract a day. You're basically time traveling 24 hours into the past. If you cross it heading west, you add a day, jumping 24 hours into the future. And here is a totally mind-bending reality of this system. Tonga and American Samoa share the exact same time on the clock. But because they sit on opposite sides of the international dateline, they are exactly one full calendar day apart. No way, right? And finally, Section 5, Great Circles, Modern Navigation. How do we use this incredible grid to actually travel the physical globe efficiently in the modern day? So in geographic geometry, we categorize the lines into great circles and small circles. A great circle center perfectly coincides with the center of the Earth, which means it divides the planet into two totally equal halves. The equator is a great circle, and importantly, so are all the longitudes. Small circles, which are all the other latitudes, don't divide the Earth equally. But the real magic of a great circle is that its arc is always, without fail, the absolute shortest physical distance between 2 points on a sphere. Why should you care about great circles? Well, because this spherical math literally dictates modern global travel. When massive ships and aircraft embark on long-distance international routes, they don't follow a straight line on a flat 2D map. They follow the arcs of great circles. Doing this represents the absolute shortest physical distance over the curve of our Earth. So a flight from New York to Mumbai relies on this exact math, and it ends up saving massive amounts of jet fuel and shaving literal hours off your flight time. So here's a final thought to leave you with. We started with a featureless spinning rock in space, and we tamed it with invisible geometry. How incredible is it that these entirely man-made imaginary lines manage to completely dictate everything from the moment your morning alarm clock goes off, to the climate you experience when you walk outside, to the exact flight path of your next international vacation? It is literally a hidden matrix that runs our world. Thank you so much